calculator. We are going to use him just a little bit today. Not tons and tons, but just a little bit. If anybody's just joining us, I'm having everybody get their notes ready to go before we start covering today. Okay, so today's a little rough. How's the weekend? Is the weekend all right?
Very good.
Very
Pretty good.
Very Okay, I think most of you guys are ready for the next page. I'm going to get that level. Why don't you skip 2 lines for this one? I think just 1 for that one should suffice. Just 1 for that one should be okay. The little graphs that are underneath, we're going to actually throw little sketches of the functions in those graphs. They don't have to be super big, but just enough you can get the main idea of what the picture looks like and what the function looks like. Just Jack's comment again. Remember, guys, today is my meeting day during lunch, so I won't be able to help you on corrections then. But I will be able to help you today after school, 7th period, if you are on a sports team where that might be easier. You have to eat. Of course, tomorrow during lunch, you're going to have as well. Corrections. I'll do tomorrow by the end of the day. Benson, you were gone on Friday. We took a quiz, so you're going to need to come in after school today or lunchtime tomorrow. Should one of those work out? Should one of those work? For the rest of you guys, as soon as Benson takes it, I can pass it back. That way you can use them to study or use it to study for your test that's coming. Almost there? Okay, look up to the front really quickly. If you're not there, see how much space to skip. I'll do 30 more seconds. Sometimes it's a little too hard to do this, but I like having you guys take the notes ahead of time if the notes are kind of conducive to it, because then you can focus, I feel, a little better when we go over it. Okay, I'm going to go ahead and change the page. Go ahead and see how much space to skip. You might need to come back to this when we cover it. But there's one more page. Let me zoom in. Once you get to this example, I'll know that you guys are all cut up, because then you can put that function in your graphing calculator and see if you can make both your tables setup and your table match mine. So once you get to this page, then go ahead and throw this function into your calculator, y equals, right? See if you can remember where the table setup is. I almost gave you the answer. And if you can make your table look like mine. I'm going to pull up my calculator while you guys write. We're going to talk about this part just for a little bit before we go back to the other parts. Just to make sure you guys are okay on your calculator. And if you're down with the function, see if you can make your calculator match mine. There is a way to do this without a graphing calculator, but it is a little advanced. I'm still going to show you guys. It's something I've required honors to do a little bit more practice with. How to do this without a calculator, but I'm still going to show it to you guys because it is a good skill. And some of you have the mental math capacity to totally be able to do this. But I do want to show you how to do it in the calculator first, but we have to make sure that you can use your calculator well. So how did you guys get, did you see behind, or I should say in the bottom left-hand corner behind the calculator now, but how did you get to this menu? How do we change the table setup? Good. Second window. Then you wanted it to be ask instead of automatic. Some of you needed to change that. If you had stuff, once you went to second graph, once you went to the table, some of you had to go and delete. You can delete any entries that are already in there. Or you can just overwrite them. That works also. My question to you is, as we look at this table, and as I specifically have you guys look at the x values, there's a math board that we've been kind of trying to learn a little bit this chapter with a symbol of an arrow that kind of describes what I'm doing as I type in each of these values. Do you guys remember what that term is? The term symbolized by an arrow. We talked about it with end behavior. It kind of has to do with what I'm showing in this X menu. Arrow. X, arrow, infinity. As X, arrow, infinity, comma, yeah, f of X approaches. Can you guys tell what value I'm trying to approach when I plugged in negative 0.5, negative 0.9, negative 0.99, negative 0.99, negative 0.99? What was I approaching? Close. Negative 1, right? Think of a number line. Now, my question to you is, and we need to label it with one or the other. Am I coming from the right? Think about a number line, like an x-axis. Am I coming from the right of negative 1 with this table, or am I coming from the left? Yeah, I am coming from the right. Because think, negative 0.5, negative 0.9, negative 0.99, negative point, I can't even show it, right? My marker's not thin enough. But yes, I am coming from the right. So I want you guys to go ahead and label this table with from the right. And technically, guys, on a number line, those numbers that are to the right of a value, aren't they technically above? Are they technically higher? Now, I know that you're like seeing the negative numbers and how they're smaller in magnitude, but any number that's to the right on a number line is technically higher. So even though from the right is good, we can also say from above. I don't mean above as in the y, I just mean on the horizontal number line. These values would be higher than negative 1, or from the right of negative 1. Now, if we're talking about coming from the right or from above, my question to you is, how would you fill in this statement? Just looking at all of those values, let me get a calculator for those of you guys in the back. Looking at these values, as x approaches negative 1 from the right, from values that are above negative 1, what would you guys say the y's are doing? Going down. Good. They're decreasing. Good. All good things. But what do you think is going to happen as we keep on plugging in more negative 0.9? It's going to, well, yeah, good. The x's will get closer to negative 1, but the y's, what do you think they're going to keep doing?
Lower.
Lower. More negative. And don't say smaller, even though I know what you're saying, say lower. because it's getting really big, but negatively. Just a little clarification. But yeah, it's getting lower, 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 lower. What can I say then it's approaching if it seems to be getting lower? Seems to be approaching negative infinity. Now pause really quickly. What were the signs of all of these y values as you were getting closer and closer and closer? They were all negative. So I think there's a correlation there, yeah? We're going to use that a little later on today. Now kiddos, that's coming from the right. That's coming from above. What if I wanted to come from the left? Or if I wanted to come from below? What are some values that you think I might start plugging in? Maybe -2, but you see how we kind of started already partway? So maybe -1.5. But how can I get even closer? Yeah, -1.1 would be even closer. How can I get even closer? Over here I did -0.5. Then I did -0.2. Yeah, start adding zeros. So let's go ahead and come from the other direction. My question to you is, what is f of x approaching as I come from the left? What if I was to come from the other direction? Yeah, nicely done. Let's see if everybody else agrees. It could have been -infinity. But as you guys are looking, now here's something a little trippy. I want you guys to actually type in -1. Is that a little tricky?
Yeah.
How can -1 be 30,000 and error?
Twice.
Was that really -1, the second to the last? What was it? -1.0001. I could even have -1 look like it's something else. I could do -1.000001. Now all of a sudden it's 3 followed by 6 zeros. Remember, your calculator has to round at some point just to display what's going on, but it understood you put in this huge number, and it plugged it in. -1 actually doesn't work, and maybe you can tell by looking at the function y. -1 is undefined, but -1.000001 does work. Anna, why did you say positive infinity? Oh, you're thinking it'd be the other one. Okay, that's a good way of thinking about it. Here's your quick dilemma. Sadly, it doesn't always work though. Sometimes it does, but not always. But now looking at the table, I totally agreed with her. Her reasoning was a little different. It happened to work out this time. But how can we now all say from the table she was right?
As you can see,
It's going up, 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 up and away, right? Yeah. So all the signs are positive. Therefore, my function is going up. So how are we going to, first of all, label this table? And this table is a little different than the one we did, but either way, we're approaching. We could say this one is from the left. Technically, numbers on the left of the number line are technically numbers that are lower or below. Just horizontally, but numbers that are lower and numbers that are below. And from that table, we can make the statement as you come from the left. Now, there is one thing we're going to have to change. We are coming from the right, and we are coming from the left, but from the right of who or what? On the number line, but what are we approaching? Who are we coming from the right and from the left of?
Negative.
Yeah. So from the right of -1 and from the left of -1. Okay, we're going to come back to this at the end of class, but do you guys understand how we use our hands? Do you understand that when this one showed -1, since it gave us a value, it really wasn't talking about -1? Just something really, really close to it, but a little bit above or to the right. And when this one showed -1, same thing. I should have scrolled up on it. Let me go steal ours, because ours worked a little bit better. Let me get rid of this one. as we came from above, as long as there's a value, once again, it's not really -1. The calculator just has to round it at some point. And let's come back. Has anybody figured out why there's an error at -1? What's going on in this function that makes an error? The bottom can't be 0, it makes the denominator 0. So what do we have to be careful of? Whenever we deal with, let's go back to the first page of notes, rational functions. What do we have to be careful of? Domain. Nice thing is, we've already talked about this year. We know that there is a domain problem when we have a denominator, because the denominator cannot equal 0. So to find our domain, we're going to take our denominator, set it not equal to 0, and solve. We're going to take our denominator, set it not equal to 0, and solve. Now, just a few of you might be like, wait a minute, whoa, we had homework due today. Why aren't we going over homework? Let me quickly go ahead and explain. This week is weird. Everybody knows that, right? Okay, because Wednesday you non-seniors have PSAT. Afternoon, period 1 through 4, so you guys should be back to me on Wednesday. So we'll have class like normal, but period 2 won't have me at all. So what I'm doing is I'm saving all homework checking and questions till Wednesday on sections 2.5, which was due today, and 2.6. So on Wednesday, we as a class will go over the homework questions. I'll record it, and period 2 will know that they need to watch the video in order to get those evens and to check and to ask and to hear some of the homework questions. Does that make sense? And then after we finish on Wednesday checking 2.5 and 2.6, then I have to actually change my calendar just a little bit. I totally forgot, although I should have known. Wednesday. Wednesday is PSAT. Friday is minimum day. So should we have a test on a minimum day?
No.
So what I'm going to do instead is 2.7 is not going to be on the test. So 2.7 we're actually going to cover on Friday, kind of like as a end of chapter 2 after the test, because we'll just have our half day be covering 2.7. There will be a homework due. Technically, it will be after the retreat. Any seniors who don't go on the underclassmen retreat, you can work on homework on Monday and Tuesday and not have to worry about it over the weekend. But those underclassmen, you'll just have a homework due on Wednesday. You can do it over the weekend. No big deal. So 2.7 is going to be outside chapter 2. It will not be on the test. The test will be on Thursday instead, so you can have a full class period and not be stressed. And if I was to cut the test down, you guys know every question would be worth like double, right? So we don't want that. That's dangerous. So the test will be on Thursday, 2.7. We are not going to cut it for the test. Does that kind of make sense? I'll change the calendar this afternoon. I don't know why. I just totally forgot Friday was the minimum day when I made the calendar this week. Okay. That's why we didn't do homework questions today. Rational function, a ratio. A ratio means a fraction. The bottom can't be 0. That's how we find domain. So, the example, I only said skip one line because all you have to do is find the domain for this one. And guys, what's the domain? X
Cannot.
Good. Cannot equal -2 because the denominator cannot be 0. Are we tracking? All right. But my question to you is, what kind of discontinuity is -2? And to answer that question, we have to go say, ooh, there are different kinds. 2 of them. Whenever you have a rational function, whenever you have denominators, 2 discontinuities can occur. One is a whole, the other is a vertical asymptote. Now, you guys have already written this down. So let's go ahead and just talk about the function. And let's see the difference in both of these functions and why, mathematically, they are different and how that shows up in their graphs. You guys, as you were looking, ooh, did no one point out my typo? Non-removable can't be factored out. So removable, did anybody already figure this out? Can be factored out. Non-removable cannot be factored out. Removable can be factored out. What do I mean? What can you guys do to this function? Factor. And as you factor the top, what do you get? Good. Difference of squares. Can you, another way of saying factored out, can you reduce? Yes. And so we can say f of the function can be rewritten as t minus 1 such that t cannot equal, why do I still need to write this?
Oh, because that's the denominator.
That's a domain restriction, right? The denominator cannot equal 0, so t cannot equal -1. I can't lose that, even though I'm making everything easier and simpler by reducing. I can't lose the restricted domain. Now, one quick little thing I do need to change. Guys, t is just taking the place of x, right? So technically, he wouldn't be named f of x, he would be named f of t. We've seen in like chapter 1 with word problems and whatnot, x can be called all sorts of different variables. You just need to know what he looks like. So we have f of t equals, or y equals, if you want to write it like that. We can rewrite this whole function. It means the exact same thing as this guy. Removable. You can factor and reduce. So what does that mean on a graph? Can you guys tell this is a line? Probably not from here. But can you tell from here he's a line? What's the equation of a line? Y equals mx plus b. So what's my b if I have the equation y equals 1t minus 1? Good. What's my slope? Up 1 over 1, up 1 over another 1, back 1, down 1. Except, what am I going to do when I go to graph at -1? I am going to draw a line, but what am I going to do when I get to -1? Skip it. I'm going to go, 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 skip. Go, go, go. Why am I skipping -1? Exactly. So, whenever I have a hole, I can cancel it out, but I need to remember, ooh, some problem still exists at that place at -1, and when I go to graph it, I can graph whatever's left, totally ignoring the nastiness that was there to begin with. I just have to remember when I get to that point to leave it blank. There's a hole, there's a discontinuity. Okay, that's one type of discontinuity. Removable, it's a hole. You can see the math because the denominator will reduce. The second one, I need you guys to really quickly draw parentheses around the numerator and denominator. Now, we don't usually draw them, they're assumed. Whenever you see a fraction, you say, okay, one whole numerator, one whole denominator. But just a few of you, before those parentheses, wanted to kill poor little kittens. That sounds so awful. You wanted to cancel out those 2's and those x's, and sure, why not the pluses too? And how awful and illegal is that? Very awful, very illegal. None of those can be reduced. Why? When you show the parentheses, do the numerator and denominator match? No. You could write this 7 over 2 plus x plus 2x over 2 plus x, but none of that will reduce. They have to match perfectly, and they don't. So therefore, the factor, the denominator, cannot be factored out. It cannot reduce. So, yes, the domain is restricted. Yes, x is not allowed to equal who? -2. But what does the graph look like? Ooh. We weren't able to reduce it. How do we know what the graph looks like? Let me help. Go by faith. And as we finish this section today and tomorrow, hopefully it'll make more sense. But first of all, at -2, we're going to put, I know you guys have drawn these before. We're going to put a vertical asymptote at -2. Hopefully that makes sense. The struggle now, though, is how do we get a graph? This lesson, we're going to talk about how there's something called a horizontal asymptote also. This one happens to have one at y equals 2. Has a vertical asymptote at x equals -2. Has a horizontal asymptote at y equals 2. Well, now how do we graph it? You could find x and y intercepts. We'll talk about that later on in this section also. You already know x-intercept plug in y is 0, but some of you would have issues plugging in y is 0, realizing it would be at -7/2. But -7/2 would put it over here somewhere. At -3.5-ish. The y-intercept plugging in x is 0. Well, that's easier. Can anybody mental math that? Plugging in x is 0? Yeah, if x is 0, what's my function end up equal? Good, just 7/2 is left. So we could find intercepts. They're going to be a little tricky because of the fraction, but not awful. Maybe some of you could guess what it looks like. Horizontal asymptote, I know it somehow needs to come towards. Some of you know that it needs to cross through those points. So maybe you could guess. But the next page, what we were doing in our calculators just a second ago with the tables, was allowing us to not only know there is a vertical asymptote, but already know or be able to find out what the function is doing as it goes towards the vertical. This one, as I come from the left, the function goes to negative infinity. As I come from the right, the function goes to positive infinity. As I come from the left, it goes to negative. As I come from the right, it goes to positive. Let's talk more about that behavior. Now, that graph I just made, I used all sorts of stuff, intercepts and horizontal asymptotes that we haven't really reviewed yet. So I showed you one. We'll get you there. But first of all, before we do that, let's talk about behavior near vertical asymptotes. So how do you get a sketch if you don't know exactly what the function is supposed to be doing? As Anna showed us earlier, you can guess, and sometimes it'll work out okay. I want you guys to think of how to fill in those blanks, and let me show you the 4 different ways, the 4 basic ways a function can approach a vertical asymptote. So I'm drawing 4 different graphs. They all have approximately the same vertical asymptote. We can have one like this one, that from the right it goes down, and from the left it goes up. But we could also have it going the opposite direction like the last one, and it was even shifted up. Or it was going, the function was going to negative infinity from the left and positive infinity from the right. But guys, can you think of any other way that we can come towards a vertical asymptote? What if they both did the same thing? Still vertical asymptote. And so if that's possible, then what else is possible? Okay, so how do we know which is which? We have to figure out this behavior thing. But the first question to ask yourself is, well, no matter how you come in towards a vertical asymptote, isn't the function always going to some sort of infinity? So those are our blanks. What are the 2 different infinities it can approach? Yeah. You either approach positive or negative infinity. We just have to figure out which one. Now, for those of you that like mental math, that plugging in the table was kind of brutal and a little bit annoying. Now some of you are like, no, I love my calculator. So maybe you had fun. But the rest of us, it was like, ugh, isn't there a way to actually solve this and not have to go to our calculators and figure it all out? The answer is yes. You gotta hang in there. The answer is yes, you gotta hang in there. My question before I go to show you the by hand way, which doesn't need a calculator, doesn't need plugging in values, doesn't need this whole like looking at all of them. My shortcut says, what were all the signs of the y's again? As I got really close, negative. And what was the sign of the answer? Negative. So the signs were negative, and the infinity was negative. True? I think that's kind of important. What are the signs of all of these? What's the sign of the final answer? Understood positives, right? So question, do you think I really cared about the 30 and the 3,000 and the 30,000 and the negative 3,000 and 30,000? All I cared about was the sign. A vertical asymptote, the answers will always be in infinity. So let's figure out how we can do this without a calculator. Let's figure out how we can do this without a calculator. From the right. Trying to figure out the behavior from the left. We still have the exact same function, so its domain is still x cannot equals negative 1. We know it's a vertical asymptote because top and bottom doesn't matter. I can't reduce, it's not a whole. I'm trying to figure out the behavior so that when I go to graph, I have an idea at this negative 1 what my function is doing as it comes in. We haven't reviewed horizontal asymptotes. We might be able to get to it really quickly at the end of class, otherwise that'll be what tomorrow's for. horizontal asymptote would also help. For this one, I'll help you guys out. It's actually the horizontal asymptote is at 0. We'll review that tomorrow. But we're trying to ask ourselves, is it going down as you come in, or is it going up as you come from the right? Is it going down, or is it going up as you come from the left? How can we tell that without the calculator? And my hint is, choose a test value. And from the right, I think one of our test values was negative 0.99. You double check on the number line that we drew when we did the table. Isn't negative 0.99 a little bit to the right of negative 1? Okay, and what's something, just choose one, maybe the same number of decimal places that's on the left of negative 1. 30 is the y value. Think about the x that goes with it. Yeah. And you could do negative 1.1 or negative 1.01. We don't want to do 1.99 because that'll get us close to negative 2. That's far away. We need to zoom in really close. And we're going to plug these in. Now you might be like, ugh, plugging in, I'm not so good at that. I know. But hold on. On the page before, did the numbers matter or did the signs matter? That's all we need. All we need are the signs. So let's go and take our function, negative 3 over somebody plus 1. Negative 3 over somebody plus 1. Let's plug in our somebodies. And my hint to you is, how do you do it with math? You plug in a test value. Now you have to make sure you're approaching, being really, really close. Plug in a test value and check the sign. Now here's the point. Sorry, that's a C. Check the sign. Here's the point. I don't care what it actually equals. If I did, then you'd have to use your calculator anyway or have to deal with fractions and decimals and all this craziness. I just care about the sign. And guys, a negative 3 is always going to have what sign? Yeah, it's going to be negative. What's the denominator going to give you? Negative 0.9 or negative 0.99 or negative 0.99 plus 1. Who wins? The positive wins. If you have a negative number over any positive number, your answer is going to be what? Negative. Does it make sense why I can say then, after that, x must be approaching negative infinity from the right? Double check with the table, isn't it the same thing we got? Without having to use a table. Well, how about over here? From the right? Negative infinity, why? Because we checked the sign, we don't care about the value. How about over here though?
Positive.
Yeah, because we're going to have the negative 3 always being a negative denominator. As we get in closer and closer, it actually ends up blowing up the number, but what's the sign going to be? And what's a negative over a negative? You don't need your calculator for this. All you need is to plug in a test value and check the sign. Chapter 2? I believe so. My question to you is, which one's going to go faster? I would say this one if you do it right. If you do it wrong, then maybe faster isn't better. But in preparing you for SATs and preparing you for college entrance exams, my tests are pretty packed as far as like using the period. So this would save you time. Okay, this is where we're going to end today. Remember how with all of my graphs I've been saying horizontal asymptotes? They're kind of important. They actually make a big difference as far as where we know or how we know to extend our graphs to the right and to the left, like towards the ends. So we're going to end with this. Horizontal asymptote is going to occur whenever your y, so your function, approaches a number or a constant, not an infinity. If you've done the end behavior, how f of x goes to infinities, those are for polynomials. For rationals, sometimes the function comes in towards a number as x goes to negative infinity or to positive infinity, which means to the right or to the left. And this is referring back to end behavior. Going to the right, to the left, is the function going up, is the function going down? Is it falling, is it rising? Well, sometimes it comes in towards a number. And if you guys realize, we need to review tomorrow something called degree test, which you learned in Algebra 2. So if you're working on homework tonight, and if you want to quickly check out the section, I bet degree tests will be reviewed in their class. First priority, test corrections. Second priority, start section 2.6. Bye guys. See you later. Tomorrow is our finishing 2.6 day, the last section before the test. Just to be aware.
Do you have a question?
Yeah. Thank you.
看有没有这个东西，就它会给你画一个，这里画一个，这边是一个什么数字，然后就直接把它拉下来。听得懂啊？这是画一个，看了图好不好？不是中文，我讲一下。就这个。
And so I couldn't put it.
Justin. So tired.
Yeah, well, no, it was actually my nutrition. I just never really got to check it. Let's check it. Done, done, done.
Delicious.
Don't feel stupid.
Steve, make them feel stupid.
Steve, do you have any other recommendations?
Recommending you? You're going to college?
Oh my gosh, David's going to college.
Which one are you applying to?
I'm applying to places.
Applying for CSUN. What time do you want us to come in? 12:10.
They're painting them something. I don't know. Hopefully not. Because if the inside's one color and the outside's another color. I'm recording this.